Okay, actually, we're going to wait for Hemant, and Hemant is joined, and Troy.
Okay.
And before we get started, okay?
Yeah, sure.
Yeah, Dr. Pancha, I'm here. Hey.
Okay,
Yeah.
I know Hemant, you're there, but I'm waiting for Troy.
Okay, thank you.
Okay, Troy is in. So we have all the committee members, and Akshar, all the best for your thesis defense.
Thank you so much.
We will first let you present your work, and then we will then have one round of questions or more rounds of questions as appropriate. And if there is more time, we'll also make sure that the audience, if they have any questions, they have a chance to interact too. Okay.
Sure.
All the best. Take it away, Akshar.
Yeah. So hi everyone. Thank you for joining me today for my thesis defense. I'm Akshar Patel. I'm a master's student studying computer science, and today I'll be defending my thesis. The topic of my thesis is accessible retail shopping for visually impaired using deep learning. So the motivation for this topic of thesis comes partly from my work at my startup. So at my startup, we were creating a social network for travelers. And considering we were competing with a lot of different social networking sites, we knew how important each was.
I have one more. I just have a comment to add to that. Is there any?
So I'll continue.
Okay, everyone on the call.
So I think we should. Go ahead. Everybody should mute their phones. Mayur, I see that you have not muted, so you should mute yourself. And Asta Banzal, you should mute yourself. Asta Banzal, mute yourself. I still see you not muted.
Akshar, would you mind making me co-host? I can take care of muting people myself as we proceed.
Okay.
Yeah,
sure.
we anyway need that, Akshar, because when we come to the end, we will need somebody to put everybody in the waiting room. So just make him a co-host, and then he can take care of that. So
yeah, sure.
By that.
Yeah, I did that.
Thank you.
Great.
Yeah.
Okay, excellent. Proceed.
Sure. Yeah. So we knew how each and every user was important, and knowing that each and every user is important meant designing an app in such a way that every user that comes to app has a very good experience, regardless of their limitations. Another motivation was my trip to China. So I had an 18-hour layover in China, and I was, as a vegetarian, I was trying to go from retail shop to different retail shops, trying to find something to eat. And I didn't know if I could eat something, partly because I couldn't understand the language, and I had no way of knowing what the ingredients of a particular product were. So that gave me an idea of trying to design a system that that identifies what a product is just by looking at the image of the product. So that's the objective of my thesis, to improve the shopping experience of shopping in retail stores for visually impaired by creating a system that recognizes the product, and creating different data sets that helps in improving such a system. So since this focuses a lot on retail aspects of shopping, I would like to go into what the current apps are doing right now. So Walmart, Target, Safeway, Sam's Club, Kroger's, all of them, they work on like scanning barcodes and using that barcode to identify what a product is. But But scanning barcode is not always intuitive. You don't always know where the barcode is. Also, if the product is really heavy, rolling the product around is not generally a good idea of trying to find a barcode. Google AI Lens does a very good job of making like identifying the product really accessible. So it just all you have to do is take an image of the product, and it reads the text as well as certain visual features, and it identifies the product for you. So that is very close to what the ideal system should be, and something that I wanted to develop. But the problem is Google being a search engine, when it does identify a product, it doesn't give you the information about the product, but then it gives you the search results, which then you have to manually go to each and every site to try to find if there is actually a product there, like information about the product there, and generally there's not, because the first 5 or 6 links are generally ads about different products. So to start to create a system that identifies a product, I needed a data set that I could test my system on. Now, considering in a retail store there are millions of items, I needed to further narrow down the products that I wanted to identify. So I selected the category of food. Now, again, in food, there are hundreds of thousands of food items that are available in retail stores. So I further narrowed it down to cereal boxes. So the reason for selecting cereal boxes is like cereal boxes. If you've seen them, they are really flashy. They have a lot of graphics, so they have a lot of visually identifying features. And the text on these cereal boxes are usually of using different special fonts. So I knew that down the road I was going to implement scene text recognition to identify different products. And if I had a data set where I had already labeled these special fonts, I could use these labels to improve the scene text recognition models. Another thing that another reason for selecting cereal boxes is once you take an image of a cereal box, all the information that you need to recognize a cereal box is right there in front of the camera. You don't need to move the cereal box around to find other different identifying information. So, so the first step, the first system that I created, a very rudimentary system, was to what's an image classifier for 60 categories of cereal boxes. So these 60 categories, out of these 60 categories, 59 were different cereal boxes and one catch-all category of none. And since this is just an image classifier, all I needed to do was gather images of different cereal boxes. I did that using automated scripts written, which I wrote that downloaded images from Google Search, Walmart, and since both of these weren't enough, I actually went to Walmart and captured 10 images of each and every cereal box at different angles at different angles, so that I can train the model to identify the product in different situations. So the image data set that I created has a total of 1,030 different images with a total of 60 categories. And with this data set in place, I created an image classifier using the FastAI framework. I use ResNet34 as a backbone, which was pre-trained on ImageNet dataset. So I just copied the weights over. For data augmentation, I use different augmentation techniques and different hyperparameter tuning techniques. This is one example of data augmentation. So this is just one image. So every time data loader comes to this one image and asks for the image, the data augmentation middleware, it generates new images based on the different types of augmentation techniques that you implemented. For validation set, what I did was for each cereal category, I had one high resolution image for Walmart.com and one high resolution image that I manually took, and 10% of the images from the non-category images, which came to a total of 150 images in the validation data set. And the ResNet34 based image classifier got to 96% of accuracy. So that was pretty encouraging. Here's a demo of the model being run in a Jupyter notebook. So I wrote a Jupyter notebook which selects the data, and all the images in the directory, it goes by one and enforce. And puts the output right below that. So not just a Jupyter notebook. I also what I did was I wrote a REST API that I used to serve the model, and I wrote a mobile app as well that takes the camera image, sends it to the REST API, and the REST API finds out that classifies the image and sends the information back to the mobile app, which the mobile app then displays. So it was pretty accurate. But one thing I found was, as you'll see in the demo, like under certain conditions, when two product boxes are really similar, under certain lighting conditions, it tends to get confused between two different image categories. So that was the app demo. So the problems with this approach and the reasons I decided not to go with the image classifier for the system was like every time you need to add a new category, you need to train the entire model again, and more categories you add, the more training time it takes. And as you saw in the demo, it gets confused between different images of similar packaging. And the catch-all category none to train the model to learn that is really challenging. So I went a different route, the one that Google AI also does, the syntax recognition. So syntax recognition is generally divided into two different problems. One is the text detection on the image and then recognizing the text in the image segments. The reason of even I wanted to keep both of these separate because there are some papers that combine both of these is because I wanted to effectively know on what part of the problem I should improve on to improve the eventual system that I was going to develop. So I first started with text detection on serial boxes. For that, I use craft, so character recognition for text detection. So what this neural network does is it uses VGG16 as a backbone and outputs region scores and affinity scores. So region scores are basically the probability that the part of the image is a character, and affinity scores as a probability that two characters are part of one single word. So this paper already has a pre-trained model which I use to label the text detection, the text in different images. Another thing that is important to understand, like before we try to improve this text detection, is the way craft trains. So it can either take a real world image or synthetic image. So for synthetic image, it would already have character level labels, but for real world labels, it would probably not have character level labels. It would have word level labels. So what it does, it takes word level labels along with the count of characters in those words. It tries to identify, it tries to predict the count in the word label, and tries to match it with the ground truth word counts, and then it trains the model. So I ran the text detection, output all the text detection in label me JSON format so that I could use label me tool to visualize and eventually improve the labels. Once I had the text detections, I started extracting image segments from the images. And I used the paper from the same author to do text recognition. It is one of the state-of-the-art techniques that are currently in syntax recognition. What they propose is using a combination of thin plate spline, the ResNet, BiLSTM, and attention models to convert image segments into text. And they already have a pre-trained model of this TPS, ResNet, BiLSTM, attention. So the system architecture that I eventually came up with was the mobile app sends the image to the REST API, the syntax classifier. It takes the image, it detects the text, it recognizes the text, which is input as a keyword to the search algorithm. The search algorithm outputs different categories, category IDs, which it thinks the images of, and which is displayed back to the mobile app. So here's a demo of the app in action. So it identified the special K red berries really well. So when it was taking the raisin bran picture, the actual category came second, but the first category is also very similar. So that was still okay. But the third, this third cereal box, it was completely not able to identify whatsoever. Each and like all the 5 categories were wrong. So I ran the entire system on each and every of 1,030 different images that I had taken, and I found that the top 1 accuracy is only 35%, but the top 5 accuracy is 65%. And looking at the top 5 predictions, it is easy to figure that using some NLP techniques, we can bring the top 1 accuracy to be close to the top 5 accuracy. But the major improvements need to be done in the text detection and text recognition models. So we find, like looking at the labels, we find that there are certain images where the text detection does not work properly, where it identifies 2 different words as one single label, where it should be just one word for label. And there are certain words that it has completely not labeled altogether. Then even if it has labeled something as a text, due to the fonts being really different from the normal fonts, the text recognition system is not able to identify that. So so what I did was use already labeled use the already labeled outputs and improve on those outputs by verifying each and every label. So adding labels where the craft has missed, improving the labels, and verifying the text recognition output as well. So I created a data set, and what I found was, like, when I was verifying the data set, it had more than 200,000 labels in the 130 different serial image box. Serial box images. Also, there are a lot of images where more than 100 words are not labeled. So this is a challenge to manually improve, and I needed a way to cut down the number of labels that I needed to improve to eventually improve the accuracy of my system. So what I found was, like when you're trying to identify a particular bounding box as, let's say, a Honey Nut Cheerios, you don't need all the extra information that's at the bottom of the box. All you need is the information that's at strategic places, like the top of the box. So that's what I did. I created bounding boxes on parts of the. I created a bounding box on part of the serial box that was really important for classifying the serial box as a particular product category, and only improve those labels there. And again, only these labels will be used eventually for improving the scene text and scene text detection and recognition models. So the dataset statistics that I eventually got was like from total of 1,030 images, the total number of labels are 22,000, and the same is true for total number of words, because each label is one single word, and the total number of characters is 105,000. So the asterisk is approximate because I still have to label the none category. So I still need to get into that, but that will be added here later. So Professor Heyman, he nudged me in a direction of a new vision of using the system that I've currently developed, as well as the data sets that I labeled, and using them to create a system that can learn to recognize a product just by looking at its online store listing. Now this is a really big challenging task, but to accomplish this task, what we need to do is have a data set that we can eventually use to test this system that we developed. So that's what I did. I created a data set of 20,000 products by collecting information from Walmart.com. All the 24,000. So a total of 24,000 products were downloaded, and then filtered out certain products because there were no images or no textual information in the images. So these are the different types of details that I have in the data set: the name, the brand name, the images of the product, the about section, and a lot more. So all the systems that I developed, namely the image classifier, the scene text classifier, as well as the data sets, namely the image classification dataset, the text detection dataset, the text recognition dataset, as well as the 20K production dataset, 20K product dataset. I'll be posting the links to all of these on the accessible shopping GitHub project page. So you'll be able to access those datasets from there. That's all the work that I have in my thesis. Thank you, Professor Punch. Thank you, Professor McDaniel, Professor, and especially Professor Heyman, for allowing me to work on such an amazing topic and guiding me through each and every step of the thesis. Thank you so much, and I'm open for questions.
Great job, Akshar. Fantastic engineering challenge that I think I was telling Hemant that several years ago we built a internal shop prototype within the Cubic lab, and we were trying to do some of this stuff that we were trying to see how we can be helpful to people with visual impairments and other kinds of disabilities to be able to kind of find the products that they need to find. The other kinds of visual disabilities, including blindness. So I think what we will do is we will ask the committee members to ask questions. I have a couple of questions myself. So let's start with Dr. Hemant first.
Yeah, thank you, Dr. Panch. Fantastic work, Akshar. I know you went to Walmart. You picked up all these cereal boxes and took images. You must be wondering what you were doing there. But I know it's not easy to get this project done. I think this data set is a fantastic contribution to the literature out there. I know we haven't yet published anything, but the scope here is phenomenal, and we should publish this work. Not only just release this data set, but come up with a text-based system. Vision-based vision and language-based system for recognition. And so, on that note, I'll just ask you one question. So, you initially implemented a system to recognize the product just using the image, and then you transition to text-based system, right?
Yeah.
Why did you move to the text-based system, and what are the disadvantages with the text system?
So, so the reason for moving into text is my thought process was, how do I identify a cereal box? So how do I know what a Cocoa Puff is and what a Red Berry is? So I know it by reading that on the box. So when designing a system, I would want it to mimic human behavior as much as possible. So that's why I moved on to text. Another reason for moving on to text is because different lighting conditions completely change the output of a visual of a CNN-based image classifier. So as we saw in the demo, just moving the box slightly, like you're rotating it slightly, it changed it from a Red Berry to a yogurt, a Kellogg's yogurt. So it also another thing that I found was it's not always easy to. So if you're trying to classify in a cereal box into different volumes, let's say there's a 14.1 Oz box, and then there's a family pack box. If you want to differentiate between those two boxes, you would need to have two different categories, and again, there's a lot more chance of it getting confused because the box look exactly the similar. There's only just one banner on top which says this is a family size box, and so there's with image-based visual features, there's a lot more chance of it getting confused. With text, the disadvantage of the text that I found, especially in the cereal boxes. So I also tried this on non-cereal box images for boxes which have a really bland sort of text. It is very accurate in identifying the text and recognizing text. But for cereal boxes, and that is also the reason I picked cereal boxes, is because I wanted the system to be good enough to identify any text in any kind of scenario. Because cereal boxes have all sorts of crazy text effects, as well as different fonts. So the eventual system that I wanted to develop should have the accuracy of identifying any text, regardless of what way it is presented in.
Thank you.
Troy, any question from you, sir?
Great job, Akshar. Very exciting work. I have a few points. I know we have limited time, so brief answers are fine. Nowadays, there are a lot of applications where individuals who are blind can directly connect with someone. For example, Be My Eyes. And that person on the other end can see what their camera's picking up and tell them exactly what it is they're looking at. Obviously, that's going to give you the best accuracy because it's another human, but I'm curious to see how, from a usability perspective, your software compares once it's ready to be compared. And also from a cost perspective, that could be huge, right? Because those other systems are very expensive as a subscription service. So I think that's less of a question, more of a comment to think about in the future. But two questions. First is, I do like your original approach of just using the images rather than doing text recognition. I think there is potential there. Have you thought about, I know you have to retrain the model each time, but have you thought about an incremental learning approach? There may be some interesting innovations there to explore. However, if you do want to go with using text, have you compared your algorithm or your software to the state of the art that we have nowadays? For example, Google's Lookout app. There's a lot of apps that individuals who are blind use. So I'm interested to see if you've compared the performance there. And then lastly, have you talked to any individuals who are blind and have gotten their feedback on your system?
Yes. So one thing that I did was compare the output of my system to Google AI Lens. So Google AI Lens is pretty accurate, but then it's a proprietary system. There's no real alternative that's as accurate as it is. So I wanted to create a data set that actually people can use to improve their own systems on product detection, the product classification data sets. In terms of talking to people, I did pitch my idea to. I'm forgetting the name. Hemant, if you can remind me.
Brian.
Yeah. Sorry, yeah. So I did pitch the idea to Brian, and he did say it was a really good idea to explore. But I haven't looked into the apps that they use to identify if there's a product there, like to classify different products.
Okay, thank you.
Okay, Akshar, I know increasingly the world is becoming a smart place, right? So every one of these products is going to have some kind of an RFID tag or some kind of a tag that's going to obviate the need for having any vision or text-based recognition approaches at all, okay? So have you thought about the overkill sometimes and sort of not only a vision text system as a hybrid system, but actually vision text RFID hybrid system that you only use the text recognition and or vision recognition in cases where it is needed, but in most cases, if it is not going to be needed, that you would not waste your cycles doing that. Have you thought about that?
Yeah. So what I eventually envisioned this being used in combination with either a barcode or an RFID tag, like what you said. So if it does find a barcode, all it needs to do is just compare the barcode ID to what the product ID is, and just show the information there. But the reason I selected this is because I did find that not all the retail apps, retail store apps, they don't usually use this technique. or they don't use any sort of a technique that improves accessibility while shopping in the apps. So this was something that I worth considering investing into. But yes, like you said, if there is a way of not going this route, I would rather take that rather than face all these inference cycles.
It's a good piece of work because no matter what, you will never automate everything that is out there. So this is a very valuable thing, and it doesn't necessarily reside only in the realm of shopping. There are so many other text-based activities that can be very helpful. So this has far-reaching implications than just only shopping in a store. So the fundamental concept is rich and valuable and applicable no matter what. So really appreciate again the fact that you have put a lot of effort in terms of engineering this to a good potential solution pathway for people who really need them. And so thank you so much for your efforts and a great job with your defense. So we're going to put you in the waiting room, all of you, and then we'll quickly have a discussion and then come back to you in short order.
Thank you.
You're welcome. We still have Akshar there.
Akshar, I can't put you in the waiting room, it looks like. So
You have to
make Troy the host.
yeah,
Okay,
you got to
got it.
transfer your host rights.
Oh, sorry. I'm so sorry.
No worries. I could take care of adding everyone back in.
Sorry.
No worries. Okay. Did you transfer? Okay, great. All right, just 1 second here. I think you had the record for number of people attending, almost 30. So
yeah, I was going to say that. That you have the record. I was going to make the point after we come back.